My name is Francisco. I work for Google, and today I'll be telling you about how we are migrating to Python 3. Along the way, I hope to share some ideas that may be useful to you at your scale. Now, fair warning, some of these tips I hope, will generalize well. They will adapt well for middle or lower scale, but they will not all be like that. So do apply very, very large and generous amounts of common sense. Not everything that a big company does is the right thing for you. Some things definitely, but not all. And if you have questions at the end, we can definitely discuss them. All right, so let me provide you a bit of the context. Google codes into a monorepo. We don't have a lot of small repositories. We have one colossal, gargantuan repository. It's a bit of a non-usual choice, but it works really well for Google. It comes with a lot of trade-offs. And we built using Blaze. Some of you may know Bazel, which is an open source build system that we created and published. We basically use Blaze, which is that plus a few extensions so that it works well with our build systems and things like that. We, like everyone else, Python 3 lifetime has come to an end, and we are now working with limited support. We have a plan to actually phase it out entirely, but it's really tough because we have a very large code base. Now, we thought maybe we'll just have a team, we'll put together a team, and that team migrates all of the Python 3 code. But that's really, really tough because there's millions of modules, and they don't all lend themselves well to automation. So for one, team code moves really, really fast. Let's say I start working on a set of libraries today, and the team that owns that code is very active. Within a week, when I want to actually submit my changes, I'm going to face a lot of conflicts. The other point is that this is definitely not one that smaller companies face, but at Google, code changes hands many times. The ownership of code changes. Some teams get defragged into other locations, and so everyone at that location leaves the team, and another team has to ramp up, so they lose context. Sometimes an entire organization gets destaffed. Sometimes two organizations merge and responsibilities change. Now, each piece of code is usually stable for quite a period, but every day there's code changing hands. Some code. Some things that also can happen is that makes migration hard is where we have low-level integrations, say direct C++ integrations, or some dependencies on libraries that are just unmigratable, where the cost to migrate is too high, or that do not belong to us and cannot be migrated. Suppose we depend on a third-party library that is unmigrated and is not going to be migrated. And finally, not all code has the same strategic importance, right? You may have production code that, say, goes into Gmail or is part of something that is very, very visible, or you can have a small linter tool that is only used by a couple of teams internally, and all of that code is in the repo, and it's not immediately obvious which is the important one. So the problem statement here is we have way too much work, and we have too little structure. It's really hard to figure out how to attack it. For one, to figure out, is it even feasible? Like, we have these many modules to migrate. Is it reasonable to expect that within a certain time frame that we could have this done? Some people are going to be asking, do we even need to do it? And they should be asking that, but they need to be well informed enough to be able to make the decision. And some people are going to be figuring out how to put together a plan. That on its own is another can of worms. It's really hard to figure out how to plan it and how long you're going to need. And the engineers are going to be figuring out, all right, I want to do it, but how do I start here? Like, all right, I don't have 1 million or a couple million. I have a couple thousands of modules. My team has a couple thousands of modules. How do we do this? And then which ones are mine? It may be obvious because it's all in the same folder, but sometimes it's not, because you've contributed code elsewhere, because you're depending on code that is in a certain other location, and you think it's owned, but sometimes it's not owned. So it's very easy at this point that you get overwhelmed by the lines of code that you have, by the fact that many changes are happening to the code at the same time that you're trying to migrate it, by the fact that you need to change a lot of things, and maybe on its own it's a complicated thing, by having too many dependencies, and so you have to do a lot of work before you even unblock a module that is very strategic for you, how fast you can go, and the number of people involved. All of this can be overwhelming. So let's talk about the mechanical transformations that you need to do first. So what you're looking at here is, imagine your dependency graph between modules, all right? And let's say that all of your graph is Python 2 only. This is the tip of your graph. Let's say your graph is gigantic and goes way below the slide, and very wide and very deep. And this is just the top, all right? So these are the leaves. lib1, lib2, and lib3 are leaf nodes in this directed graph, and they do not depend on anything. Because they do not depend on anything, you can actually go work on them. And when you do work on them, our recommendation is that you make it such that the code that you leave behind will still execute well in Python 2, but will also execute well in Python 3. So this way, if a library is Python 2 and 3 compatible, it can be imported. It can be part of the transitive closure of dependencies for any binary in the company. And then the binaries that only depend on Python 3 things, well, you can switch them to run in Python 3. And the other ones, well, they're fine still running in Python 2, because if something requires lib1 and lib3, lib1 and lib3, and lib1 is Python 3 compatible and lib3 is only Python 2 compatible, then you can still run in Python 2. So the idea is ensure that you go for simultaneous compatibility between 2 and 3. It's a little more work, but it makes it so that you don't need to bulk migrate everything. You can migrate bit by bit, incrementally, and this is a saner way to actually roll anything out. You can't just one day go like, all right, I've migrated all of my project's 1,000 libraries, let me commit this thing and push live to production. That's not going to work well for anybody. This also allows you to detect regressions, because if you change code and you break something in Python 2, you'll have a lot of targets in Python 2, a lot of dependencies, perhaps tests that are actually going to break. And if you break only the Python 3 side, ideally you will accumulate tests that run in Python 3 over time as you migrate them. That will also tell you if you broke something. So the idea of having double compatibility allows you to prevent regressions on both sides. And so now we discussed this library 1, library 2, and library 3. They are unblocked. You can go work on them. And now if you migrate the libraries 1, 2, and 3, you literally unblock the work on libraries 4 and 5, right? So if you return our thought from this is the graph of dependencies in Python to this is the graph of dependencies in Python 2, lib4 and lib5 have become leaves in that new graph, in that updated graph. So you always go at the leaves, right? You work on the leaf and you unblock more work. And you unblock more work means you generate new leaves. You keep doing this. The fun thing is also, notice that you could not really work on library 4 and 5 until you actually migrated the last one of libraries 1, 2, and 3. But as soon as you did, now you've unblocked. And maybe library 4 and 5 belong to different teams, and now they can work in parallel, right? So unblocking, you can be strategic about this. We'll talk about that in a second. So just keep doing that until you're done. In practice, your dependency graph is going to be, as I said, much larger than this. And how large it is depends on your specific project or company. But here's an interesting idea that actually helped us a lot. Especially if you're medium to large sized, consider introducing a mechanism to prevent backslides, meaning someone going back and breaking Python 3 again and relying only on Python 2. So the idea here is that once you go Python 3 compatible, you have some mechanism that prevents you from going back. And the ideal way would be to have a test that actually runs in Python 3. So if you can also migrate your Python 2 tests, if you have them, to run in Python 2 and 3, and then you actually run them both in parallel, like daily or hourly or whatever your release cycle is, then you all know or even on pre-submit, even on as a pre-commit hook, then you will know, wait, I'm breaking something. Let me not go ahead before I actually break something for someone else. All right, let's talk a bit about tooling. So if you run your tests both in 2 and 3, like I just said, then you're golden. Otherwise, you'll probably need to create additional process and get people to sign informal agreements and things, not sign, but to commit informally to agreements in issues in an issue tracker or something like that. One thing to know is the Modernize tool is really, really solid. We found that whenever we wanted to automate big batches of migration, we could just start by running Modernize blindly. It is so solid, and then we would go and hack at it manually. This is a very, very powerful tool, and I fully recommend it. And another thing to consider is using type checking. It may be the case that your Python 2 code is working fine, but it is not type correct. It is incidentally working fine, because the confusions with strings and just the fact that sometimes you can pass a type instead of another type, and it will sort of kind of do what you want, or at least it's a semantic bug that doesn't manifest in production. It might just be a bug that where a typed language you would have caught. In this case, you didn't catch yet. And there's lots of those around. I can tell you there's lots of those. So if you use something that is really low cost, and we use PyType, but I hear good things about MyPy, which is actually far more used. If it does not force you to annotate anything, PyType doesn't. It tries to do type inference. You can annotate, but you don't need to. It will already, out of the blue, tell you, hey, there's something wrong about this. This specific parameter is this type. You're passing it along like this. You probably want to convert or something like that. So the good thing about this is, if you actually go through the trouble of adopting a type mechanism, even if just advisory, then you can actually spot bugs in your Python 2, and you can fix them in Python 2. And then as you migrate to 3, if a bug starts showing, you will know that it's because of the 3 conversion. You won't be guessing, well, did I just spot this incidentally on 3 because of 3? Was this already in 2? And then if you need to roll back to the Python 2 version, you know it's safe because you checked it. Well, you have a strong suspicion that it's safe. It is still a dynamic language, so you can't really know for sure. But you're more confident that if you go back to your previous version, you're going to be all right. And an important piece of tooling we created for ourselves was instrumentation. Now I'm going to describe something that is very costly. So it's definitely not going to be a good plan for many of you. But for a number of you, I hope it is. And this, to us, made the difference between we can't even approach the problem or we are nearly done fixing the problem. So we spoke about the dependency graph, but as just on a slide, it's just a concept. The idea is you need to build it, and you need to instrument it. You need to be able to, and you need to be able to build it on a schedule and refresh it on a schedule once a day, maybe twice a day. So you should be able to actually easily see the things that are already done and how much is left to do, and what exactly are the things that are left to do, and make priority calls. If you're thinking how to build the dependency graph, there's module graph. It's on PyPy. It's actually rather interesting as a tool. We didn't use module graph. Because we use Bazel, it provides us with querying mechanisms that allows us to actually go and extract information from the individual nodes on the graph, and then from that information we basically created. For those of you who are familiar, we created Dremel tables. There's a paper, an open paper about Dremel, and it's basically just a NoSQL storage system, and then we can just issue queries on it. And everything that I said about what we measure and what I'll show you in a second is basically coming from live queries on that data that is built from this dependency graph. So I cannot speak enough good things about Bazel because it is a very powerful tool. And things like who is owning something? Can I try and figure out where in the company this is kept? So this presents also an opportunity to clean up your house. Let me show you a couple more interesting questions that we enabled ourselves to ask and answer just via dashboard. Is a specific module Python 2 compatible, Python 3 compatible, or both at a glance? Do we know? And what do we, like, the definition of what Python 3 compatible is going to be depends on you. You get to decide what that means to you. We decided something is proven Python 3 compatible if there is at least one Python 3 test that runs that includes that thing. And this does not give you a very, very high confidence level, but it gives you some confidence, which is much better than no confidence. Other things that we'd like to understand. This specific module that I'm working on, or that I'd like to work on, how many things are blocking it? How many things does it depend on that are still Python 2 compatible? Likewise, if it is a leaf of mine that I could work on, how many things is it blocking? Because then I can be strategic, right? I can go and figure out what is the thing that I can work right now that will then block the most amount of work, because then we can parallelize more. Maybe more teams will be unblocked after that. And then individual teams can say, hey, within my project, if I restrict this whole graph just to the subgraph of my project, what are the leaves there? What are the unblocked things there that I can work on? Is there anything unblocked right now, or am I still blocked by something else? And who are those people, and can I go talk to them? And again, where are the bottlenecks? What are the things that are causing the most constriction in the migration process right now so that I can go work on? Now, this is a wonderful opportunity to just drop your dependency. And this sounds like a pipe dream, but the fact is sometimes there's another new library that you've been meaning to migrate to, but you've been putting off that work because, well, the old library is serving you well, and the cost-benefit analysis is like, well, why migrate now? Let's migrate when we need to. And now the fact is, there's a cost, right? And the benefit is low, but now that cost is offset by the cost of migrating the old thing. Should you migrate the old thing? Maybe just drop it. Maybe it's cheaper to just migrate to the new thing. So it's an opportunity to clean up what you are working with, what you have in your dependency code, in your dependencies, and make your code more robust. If you're stuck wondering, and this is for PM type people, if you're stuck thinking, should we just drop this? Then we created ourselves a 6-point path. What is this fixing? Why is it fixing that? Because maybe we don't need to fix that at all. What do we want out of this? And when do we want to have a solution for this? What's our path to get there? And importantly, how costly can we allow this to be? And it's about offsetting. So I'm not going to bore you more with that. Let's move to the next one. So we spoke about a couple of points where you can be strategic in how you choose what to do next. So some things have high business value. They're business critical for some important project or for some important deadline that is coming up for a delivery. Or they are of high reputational value. I can tell you internally, we prioritize migrating some very high reputation libraries because everyone is using them. Once they realize they're Python 3 compatible, maybe they get a tiny extra cognitive psychological push to actually, you know what, we should actually think about doing this ourselves. And the bottlenecks are, like I mentioned, the ones that are blocking the highest number of modules. So you can maximize the parallelizability. And you will need to balance how you want to actually, like, you can go strictly for business critical modules, but eventually you'll run out of those. Or you can go strictly for bottleneck to maximize parallelizability. Or you can blend them, right? You're probably going to blend. You're going to learn about criticality as you go, and you'll work better as time passes. But there's an important thing to know that I wanted to specifically share with you, is if you are a tech lead, or if you are a project manager, or if you are above those people. We found that there's a fundamental set of libraries that most code uses. And in any environment, you'll have built, like, some of these are some of the oldest libraries in your company. You've learned to rely on them. Simple things like the logging library that you use, or the extension to the Apache library that you wrote and that provides you the extra thing that you always have, or the monitoring library that you have, or the expansion on the RPC library, whatever it is that you use for the longest time. Some of these are going to be used everywhere. And we call those core libraries. And what that means is, because they're used everywhere, you're going to have to work on them first. Remember this example back there. Let me go back there quickly for a second, where we mentioned up until let's say you fix library 1 and library 2. You still cannot work on library 4 and library 5. You need to finish the last one of those to unblock library 4 and library 5. I imagine instead of 1, 2, and 3, you had 100 there. You need to first unblock 100 libraries. And even if you have a lot of teams ready to work right now on this, one of the things that we did with our dashboards to make it maximally useful, and basically the entry point for as many teams as wanted to use it, was distinguish between present these 4 sections that you see here, and these are screenshots. Distinguishing between the internal targets, your blocked targets, and your upgradable targets, where upgradable pretty much means the current leaves in your dependency graph. So you can actually start working on those right away. And then these are the ones that are still blocked, and you can see how many things it is blocked by and how many things it is blocking. And then outside of your code base, but still in your dependency graph, say things that belong to other teams, or that belong to core libraries at Google or something like that. So we have the dependencies that are blocking you. So you know that you should ensure that these things get migrated. You should go talk to those teams, or you should ensure that they have a plan. And these are the targets outside of the code base that you own, that are blocked by you. So if someone else is depending on your code, then you know that they are blocked, and so you should prioritize these things. Hopefully you can actually you'll know who is most blocked. You'll see, all right, this specific module is blocked by 5 dependencies on us. Which are those dependencies? And then you go and you try and find those in upgradable targets, and those are things that you should prioritize. So the idea here is that you'll get basically so what the baseline information we have is what modules we have and what dependencies there are between them. But by taking these slices of information, these joins and slices, you can actually have meaningful, let's say, intelligence that allows you to make solid business decisions, or even just solid technical decisions. Because teams are not, like, engineers are probably not going to be worrying about business decisions, but they need to migrate their code base, and they want to make sure that they're doing the right thing. So I did mention that while we could not centralize, we could not drive this centrally in terms of completing. The fact is, we actually have a permanent dedicated Python team, which could centralize some things, like creating all of this instrumentation and ensuring that teams know where to go. So there's a few things that are very important. Depending on scale, you may need more of these or less or fewer of these. But it's totally fine if you don't have a dedicated Python team. That is the normality. That is the usual scenario. However, consider that it may be useful to actually set aside a few people in the company that are going to be spearheading this intention, this project. And these are the people who are going to be creating the technical strategy and creating the instrumentation and perhaps bulk converting some things, especially if they are strategically important. And we managed early on. It was very hard for this team to do any of that work because they were doing all of the strategy and instrumentation. But later on, they started doing bulk conversions, which were really, really important. And we ended up having them contribute to about 30% of the migration centrally, which is, and mostly by using automation. But it's, a team that actually is building the automation they need as smartly as they can. And because this was being done, and they're changing code that belongs to everyone else on the company, they were sending code reviews. Code reviews is what we call pull requests. And so that meant that everyone was getting visibility and being reminded, hey, Python 3 is important. We need to get going. So I mentioned this too. If you have some strategic components that need migration, it's also possible to actually put it in the hands of the experts. Now at Google, we do something that I find one of the most fascinating things at Google, and is the fact that if you have a big program management problem, we treat it as an engineering problem. It's not immediately trivial to recast it as an engineering problem. But if you instrument the hell out of everything, after a while, what you have is a set of metrics, and it's about graph optimization or process engineering, and those are things that engineers can work with, because the company is fundamentally an engineering company. If you give them a meat space, wishy-washy people problem, well, that's not something that they're the best equipped for. But you give them things that are measurable and things that look like the kinds of problems they've been taught to solve, then they'll solve it. Now, a couple of things that have to do with change management that really should be said. This will probably not mean much to most of you, but the fact is, if you have a small company, you just need to sit together and someone needs to go, all right, this is why it's important. And everybody gets it. You walk out of the room and you're done. But if you have at least a few hundred people or more, it's going to be very hard to actually drive anything, because, like I said, it's not realistic to drive everything centrally, no matter how much you try, and you should still try. The fact is, you're going to have to convince the people who call the shots. And to convince the people who call the shots, you need to educate them. And so you need them to say, no, this is what's going to happen. This is my decision. Now, be prepared, because these people, they have this tendency to ask for a lot of estimate costs and pilots and planning and adjusting, and that's normal. That is expected. So expected to have to do a lot of work to get that. And another thing to consider is your central team. They're not going to be able to scale. The idea is they're there also to support the other teams as they go, when they get stuck, when they face something complicated. And so they won't be able to reply to everyone. The only way they can scale is by finding what are the common patterns that are not already in the Python 3 documentation, but there will be common patterns that emerge from your specific usage of the language and of libraries, and then document these patterns and how to convert them. Have an FAQ. Maybe consider having office hours like once a week or twice a week, something like that, that will allow people to not constantly interrupt them, because otherwise they're also not going to be productive. And this is actually public. It was published on a Twitter feed by Gregory Smith, the guy who works in the Python 3 team. Really, really smart engineer. And he published this. This is our current state. Now, note, this is basically me saying there's reason to not despair. Even we, with millions of modules, managed to get that close to 100%. You're probably wondering what these blips over here are. And those are good, fun points. We tried to automate something in bulk. And then, because continuous integration told us it would be fine, turns out it wasn't fine. We were missing some important tests. We rolled them back and then fixed, added tests, fixed, and then rolled forward more continuously, more progressively. Same thing with this jump, is when basically those two blips actually functioned well. This was an attempt, failed one. This was another attempt, failed one. This was that attempt plus something else. So it pays to do bulk migrations if you can afford the time and the engineering effort. Now, I should say, this graph is the end of the graph. This is after years of work from the Python team to enable integration of Python 3 into our stack, which itself was a multi-year project. Now, one thing I wanted to mention, in this last mile here, you should expect that you're going to find really complicated code, or very complicated organizations with very complicated politics. One of the two, maybe both. And at that point, throwing dedicated project managers at this and throwing your centralized team at this, because by now they actually have the experience of all of this curve. They're pretty much prepared for whatever comes at them. The other thing to mention about engineer drive, a lot of engineers will be self-motivated. I'm very confident that a lot of people who are watching right now are very self-motivated to actually get the migration like this done, because, well, the benefit is yours, right? After that, you're working in Python 3, you're not stuck to Python 2 anymore. But a lot of teams don't really have that specific drive, or a lot of engineers don't have that drive because their drive is elsewhere, as it can, right? It's totally fine. They maybe are not particular fans of Python to begin with, and that's okay. Just know that not everybody will just jump on board of your thing and say, hey, I'm just going to migrate things to Python. That's not a guarantee. So make sure that you curate and prepare your incentives. And with that, that brings us to a summary before closing and, well, before going to Q&A. So try and drive as much centrally, even knowing that you cannot execute everything centrally if you are above even mid-range dimension. Try to have that central effort to do bulk migrations, prepare the instrumentation, and prepare the documentation, and educate the leaders so that the right incentives are in place and the right communications go out. And hopefully you'll be able to get the backslide prevention so that people don't reintroduce dependencies on Python 2. But if you have that central effort, then you can actually provide people tools and data so that they can understand how far we've come and what are the things that are ahead, what's immediately on our plate right now. And if I have 2 hours right now, what's one thing I can pick? And what do I do to that thing? Like, if I don't know anything about this, how can I go learn? What are the right external documentation and internal documentation? So it's about hand-holding people, just providing the space for the magic to happen, and then supporting them when things don't go quite as well as you'd like. And then hopefully your graph will look like the one that I showed you. And that was my presentation. I hope you managed to take anything useful out of this. And I will happily take any questions. And if you want to attend the breakout session, I'll be very, very happy to speak to you. Thank you.
For your good internet connection and English articulation. Our topics can be amazing, but without technical parts, it all just breaks into things, but we are trying our best. So let me start with Ignite a question to start things. During your migration that actually continues, what was the most common issue you met?
The most common issue we met everywhere, and I could say, I'm going to guess this is going to be true for every project everywhere, is strings. Strings in Python 2 are actually become, well, what strings in Python 2 are called is what bytes in Python 3 is called, and strings in Python 3 is what Python 2 calls Unicode. And it's very subtle, because if you blindly run things in Python 3, in many cases it feels like it's working fine, and then you come and you realize that it's not working fine at all. So the conversion requires it to be explicit about when you want to encode and decode things. Not everybody is exactly ready or prepared or filled in on what needs to happen. Myself, I had to learn a little more about encodings to actually get up to speed. So it's I'm not going to say it's the hardest, but I'm going to say it's the most prevalent. And it's never obvious. It's never, ever obvious. You can't just glimpse at the code and know exactly what you want. You really need to trace the code and figure out what is supposed to come there. This is one of those circumstances where it really pays off to have type inference of some sorts. And if you're trying to solve it, I'm going to go ahead and, more than just having type inference, you should try to annotate the code with types. Because if you do, you will know for sure where things are wrong, where things are coming that they should be this type and they're not. And so it may really, really help a lot. Yes, definitely. Strings are the most common situation. A lot of things are detected by Modernize or 2-3. 2-3 is a wonderful tool. We couldn't use it explicitly for us because Well, because of our internal toolchain, it was making a few assumptions that just don't work for us. But 2 to 3 and Modernize, those are really, really wonderful tools, and you should make use of them as much as possible. They will usually introduce, there's a library called 6, and 6 has retro-compatible implementations of things from 2. It won't solve you strings, but it will solve a number of other things if you have way too much code. So ideally, you should not need 6. You should just do things natively. But you have too much code in too little time, go for the automated 6 dependencies, and it keeps things going until you have time to refactor.
Yes, explicit is much better than implicit, and
Yes.
prior to Python 3, Unicode support was hidden within all the code page, automatic conversions, and so on. After it was moved to the daylight, vampires was not that easy to deal with. Next question is from Valery Ryzhikov. He mentions your dependency graph, and is interested what kind of tools and processes do you use in order to build these dependency graphs, and most importantly, is building such graph was an obligation for the team that actually maintained the code, or do you have some company-wide initiative to build such dependency graphs for all the million models and to feed them to developers to deal with?
So thank you, Valerie. That is a wonderful, very insightful question. And it goes at exactly the core of how these things were run. So let me try and take a stab at it. Basically, I'll cover the technology and then the processes. In terms of technology, what we do is, because we use Bazel and we have this query API, we can actually go and say, hey, give me all of the Python targets in our code base, and it will just dump all of that for you. You can also say, you can also specifically query, give me all of the Python targets that are Python 2 only, or give me all the targets that are Python 3 compatible, or the ones that are both. So you can actually query individual things, and then by crossing them, you'll have the individual information. You can also dump information about, dependencies. So you can say, give me all of the things that are Python 2 modules that are dependent on by non-Python 3 compatible. So you can make those. It's a graph query, so you can select nodes in terms of what their dependencies are. And you can also dump the dependencies. So in the end, what happened was, once a day we create a massive dump of all of the targets and a massive dump of all of the dependencies, so the edges on the graph. And with those, well, you've got your V and your E, so all of your graph knowledge comes into play. Those then get exported as column.io. Well, it's not really column.io that we use anymore, but I don't know if the other thing is published yet. But column.io, there's an open paper on this as well. And basically, it allows us to point a query engine at those files, at the sharded files that contain the information that you dumped, and just write SQL on them. So what you saw, then the dashboard that you saw, is literally basically a layout with some graphs that behind them have a query. And when you open the page, the query actually executes against those files and generates a graph for you. I know that there is an external version of this dashboarding platform. So let me just quickly go find the name of that. Cloud Graphs. Don't exactly remember the name the product. But I can find it for you, and I can
Yes, that will be amazing, and we will have a Zoom room after this talk
Sure.
where
Perfect.
we can freely exchange links.
I left one part of the question unanswered, which is who gets to take care of this? And what we did was these tables were being generated internally by the Python 3 team, and they were creating some of the dashboards, and then the rest of Google could create dashboards on them too. So some other dashboards appeared, some that were better for project management, some that were better for other kinds of things. But once the data is there and it's open, well, it's funny because Google is big enough that you can actually see the kind of initiatives that you see in an open source community all inside of the company. So yes, it just becomes a very open process with a lot of people contributing.
Thank you. Next question is from Nikita, who are interested about Futurize package, and he personally finds it better for migrating 2 to 3. Does your team have any experience with Futurize package, and how can you rate it compared to packages you mentioned, like Modernize?
So thank you for the question. I'll be honest with you. I was not involved in a lot of the things that I described. I do not know. I know that Futurize was evaluated. It was part of the set of things that that was put on the line. I know it was excluded, but I cannot say that it was because it was not performant or not compliant or not good. Like I said, 2 to 3, for example, is a great tool that we ended up not being able to use just because it did not fit our particular technological trade-offs. So it may have been that this was the case with Futurize as well. I know that we do not recommend using it internally, but I do not know exactly why. But again, it's not a reflection on the quality of the tool. I'm actually pretty convinced it's rather good. I have not used it myself.
Thank you. Next question from Evgeny, who thanks you for your talk and asks, do you have plans to use any custom Python 2 interpreter after Python 2 end of life now? And if not, are you planning to migrate all the Python code to Python 3?
All right, so we are planning to migrate all the Python 2 code to Python 3. That is for certain. We have a timeline. We asked people. So to prevent the backslides, we basically forced a breakage. We said on this date, Python 2 is going to stop working for all of your modules, unless you get your module added to this allow list. And here's the process for you to do so. And the process for you to do so involves creating an issue in a bug tracker with a commitment. By date X, we expect to have it migrated. That raises a number of other problems, but at least it gives you some guarantee that people are on the hook for it, because that someone owns it and is on the hook for it. So that helps. We are trying to have everything converted. I do not know that we're going to be able to hit the target date. Knowing humans, I will guess that it's not going to be 100%. I will guess that it will be very, very close. And so at that point, probably a VP, someone really high up is going to say, enough, we're going to finish this. And then within a couple of months, it will be done. Again, futurology, I do not know, but this is my best guess. I will say, however, regarding the need for a runtime for 2, I don't know that we will need one. And this is where I'd like to. Is it okay for me to ask a follow-up question to the person asking the question?
I think follow-ups we can handle in the Zoom.
All right, then I will invite the person with this question to actually join, because if you mean specifically for cloud products, then it's a different thing, because cloud products actually run Python 2, and I'm not exactly sure what the story is there, but we can discuss.
Evgeny, please join us in Zoom so we can follow up your question. One more. You mentioned that some code involves C++ integration and is not migratable at all. You can migrate it. So what will happen with such code? Like, I don't know, Docker forever or what?
All right, let me get myself my notes. So what we do is, so all right, C++ dependencies are tough, but they're there for a reason, and usually the reason is performance, right?
Yeah.
It may just be that the reason is we have a canonical implementation in C++, and the canonical implementation is complicated enough that replicating it and then maintaining two copies is too much of a cost. So someone at some point in time paid the one-time cost of writing a swig adapter, which is painful as all to write, but then you have it, and now you have this the symbol that you can actually call, and things really work. Usually this thing happens after spending a lot of time wrangling with the thing. Um, the way we are doing this is by, one is you can if you pay attention to very close attention to how you're using strings, you can actually still have Python 2 compliant swig. So when we can, we make the C++ Python compliant, and a lot of it is already compliant. It's just we need to check. The other option is to remove the C++ dependency via swig and add one via Cliff. I think Cliff is an open source thing. Let me check. Yes, it is an open source thing. It's on GitHub, Google Cliff. So it's another wrapper interface between C++ and Python, and it generally does much better than Swig at being Python 3 compatible. And finally, if something is unmigratable, nothing is unmigratable, right? Unmigratable just means it is too costly for us to migrate than we can think to afford. And so you need to drop that dependency. It's you're stuck between bad options. You have to select one of the bad options. Either you pay a massive cost or you lose your dependency. And sometimes, if this is a very old dependency that you've had there since forever, it bears asking, what does this dependency do for us, and does our binary still need it? And if it still needs it, then all right, go make a choice. But if it doesn't, it doesn't.
Perfect.